Hello everyone, I'm Alex. In this lesson, we are going to learn about first principles of differentiation. Let's begin with the graph. Suppose we take 2 points on the curve. The first point on the left is x, f of x. And before finding the coordinates of the point on the right, if we define the horizontal distance between the 2 points as h, then the x-coordinate of the point on the right will be x plus h, and its y-coordinate will be f of x plus h. Now we have two coordinates x, f of x and x plus h, f of x plus h. The gradient between these 2 points, or the average gradient, is y2 minus y1 over x2 minus x1, which can also be written as f of x plus h minus f of x all over x plus h minus x. And that simplifies to f of x plus h minus f of x over h. Now, this gives us the gradient of the secant line. If h becomes smaller and smaller, then the second point moves closer and closer to the first point, and the secant line approaches the tangent line, which is in pink color. So in the limit, as h approaches 0, we get the gradient of the tangent line. That gives us the definition of the derivative. Limit as h approaches 0, f of x plus h minus f of x over h is f prime of x. So this is what we call differentiation from first principles. Now, there are several ways to write the derivative. You may see y prime, f prime of x, dy over dx, d over dx of f of x. This will represent the derivative. Also, notice that the average gradient can be written as y2 minus y1 over x2 minus x1, which is change in y over change in x, while the derivative is written as dy over dx. So the derivative comes from the limiting process of the average rate of change. Let's now use first principles to differentiate some basic functions. First, let f of x equals 4. Then clearly f of x plus h is 4. So using the first principles, limit as h approaches 0, 4 minus 4 over h is limit of 0 over h, which is 0. So the derivative of a constant is 0. And that makes sense because the graph of y equals 4 is a horizontal line, and its gradient is 0 everywhere. Now let's look at the next example. Suppose f of x is x, then f of x plus h is x plus h. So once again, by using the first principles and plugging the f of x and f of x plus h that we found, it will be limit as h approaches 0, x plus h minus x over h, which is limit of h over h. That can be simplified to limit of 1, which is 1. So the derivative of x is 1. Again, this makes sense because the graph of y equals x is a straight line with a gradient of 1 everywhere. Now let's differentiate f of x is x squared. First, f of x plus h is x plus h squared. That is x squared plus 2xh plus h squared. Using first principles, f prime of x is limit as h approaches 0, x squared plus 2xh plus h squared minus x squared all over h. The x squared terms cancel, so we get limit of 2xh plus h squared over h. Now factor out h, then it will be limit of h times 2x plus h over h. Cancel the h, and we get limit of 2x plus h, where h is almost nothing. So we get 2x. So f prime of x is 2x. Let's take a look at the graph of y equals x squared for a second. When x is 1, y is 1. Then what is the gradient of tangent at x equals 1? If you plug in x value to the derivative function of f of x, then you will get the gradient at that point. For this example, if you plug in 1 to x, then f prime of 1 is 2. That means the gradient of tangent line to y equals x squared at x equals 1 is 2. This is a way to find the gradient of tangent at a specific point like this, but for now, we'll first learn the method of differentiation and come back to this part later. Next, let's differentiate f of x is x to the power of 3. Then f of x plus h is x plus h to the power of 3, that is x cubed plus 3x squared h plus 3xh squared plus h to the power of 3. By using the first principles again, f prime of x is limit as h approaches 0, x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed over h. The x cubed terms cancel, and if we factor out h, it will be limit of h times 3x squared plus 3xh plus h squared over h. By canceling the h, it will be limit of 3x squared plus 3xh plus h squared. As h approaches 0, the term containing h disappears, so we get 3x squared. So f prime of x is 3x squared. Now let's differentiate a general linear function. Suppose f of x is mx plus c. Then f of x plus h is m times x plus h plus c. So f prime of x is limit as h approaches 0, mx plus mh plus c minus mx plus c all over h. The terms mx and c cancel, so it will be limit of mh over h. And it will be limit of m, that is m. So first principles confirms what we already know. The gradient of straight line y equals mx plus c is simply m. Now let's move on to a function with two terms. Suppose f of x is ax cubed plus bx squared. Then f of x plus h is a times x plus h to the power of 3 plus b times x plus h squared. When expanded, it will be a times x cubed plus 3x squared h plus 3xh squared plus h cubed plus b times x squared plus 2xh plus h squared. Using first principles, f prime of x is limit of ax cubed plus 3ax squared h plus 3axh squared plus ah cubed plus bx squared plus 2bxh plus bh squared minus ax cubed plus bx squared all over h. As you can see on the screen, the ax cubed and bx squared terms cancel. If we factor out h, it will be limit of h times 3ax squared plus 3axh plus ah squared plus 2bx plus bh all over h. By cancelling the h, it will be limit of 3ax squared plus 3axh plus ah squared plus 2bx plus bh. So as h approaches 0, we can cancel all the terms with h. Then there will be only two terms left, 3ax squared plus 2bx. So f prime of x is 3ax squared plus 2bx. Now let's differentiate f of x is square root x. Then f of x plus h is square root of x plus h. So by first principles, f prime of x is limit of square root x plus h minus square root x over h. At this point, we cannot simplify directly, so we multiply by the conjugate, which is square root of x plus h plus square root of x over square root of x plus h plus square root of x. Then it will be limit of x plus h minus x over h times square root of x plus h plus square root of x. The x on the numerator will be cancelled, so it will be limit of h over h times square root of x plus h plus square root of x. By cancelling the h, it will be limit of 1 over square root of x plus h plus square root of x. Now let h approaches 0, then it will be 1 over 2 square root of x. So the derivative of square root of x is 1 over 2 square root of x. Now let's look at the pattern in the results we have found. If f of x is constant of 4, its f prime of x is 0. If f of x is just linear of x, then its derivative is 1. And if we differentiate x squared, its derivative is 2x. For f of x is x cubed, f prime of x is 3x squared. So we can see a clear pattern here. The power comes down to the front, and the exponent decreases by 1. That leads to the power rule. If f of x is x to the power of n, then f prime of x is n times x to the power of n minus 1. This is one of the most important rules in differentiation. Now let's go back to the function f of x is ax cubed plus bx squared. Earlier, using first principles, we found that f prime of x is 3ax squared plus 2bx. We can write the derivative of ax cubed plus bx squared as the sum of the derivatives of each term separately. d of dx of ax cubed plus bx squared is d of dx of ax cubed plus d of dx of bx squared. Using the power rule, the derivative of x cubed is 3x squared. So derivative of ax cubed is 3ax squared. Likewise, if you differentiate bx squared using the power rule, it will be 2bx. Now let's apply this idea to a quadratic function. Suppose y is ax squared plus bx plus c. We can also write this as ax squared plus bx to the power 1 plus c times x to the power 0. Differentiating term by term using power rule, it gives a times 2x to the power 1 plus b times 1 times x to the power 0 plus c times 0 times x to the power negative 1, which simplifies to 2ax plus b. Now let's take a look at the graph of quadratic functions. There's a formula that we can utilize to find the vertex coordinate, that is x equals negative b over 2a. The vertex is the point where the instantaneous rate of change or gradient is 0. So dy over dx is 0. That gives 2ax plus b equals 0. Solving for x is negative b over 2a. So we have shown that the x coordinate of the vertex of the quadratic is negative b over 2a. This is a very nice application of differentiation. Finally, let's connect this back to square root of x. For f of x is square root of x, we have found its derivative is 1 over 2 times square root of x by using the first principles. And square root of x can be written as x to the power of half. If you use the power rule, f prime of x is half times x to the power of half minus 1. That is half times x to the power of negative half. So we get 1 over 2 times 1 over square root of x is 1 over 2 square root of x. So this matches exactly the answer we obtained earlier using first principles. So in this lesson, we use the first principles to understand what differentiation really means. And then we use the pattern from those results to introduce the power rule. Once we know the power rule, differentiation becomes much faster and more efficient. Thanks for watching. I'm Alex.